Hello and welcome back. In our last video, we learned the limit definition for a derivative, which works for every single function. Although the limit is often very difficult to solve, sometimes you could say impossible, but I'm not sure that it's exactly impossible to evaluate every limit. But anyways, here's a much easier way to evaluate derivatives for you. So the formula is that the derivative with respect to x, of course, of x to the power of any number is equal to bringing the n down in front of it, timesing it by x to the n minus 1. So that might seem a little confusing. So we're going to do some examples. Now remember d dx, that's derivative with respect to x. So first, let's do it. So x to the 5. Let's bring the 5 down. Times it by x to the n minus 1 is 5 minus 1. So it's 5x to the 4. Very simple. Just going to show you guys some I forgot the word, but a little long function. We can do it with ones that are added together. N to the x to the 7 minus 1, 7x to the 6, plus 4x to the 4 minus 1 is 3. And what is the derivative of a constant now? Well, we can write this constant. Let's rewrite it. 1. Remember that x, any number to the 0 is just 1. So this is 1, x to the 0. So if we bring this 0 in front, we get 0. So this is just 7x to the 6 plus 4x cubed. Boom. Derivative with respect to x of just x. Now, we could either do this, we could rewrite it as dx over dx and say that equals 1. Technically true. Technically, d over dx is a operator, so we just say it equals 1 times x to the 0, which is just 1 again. So it's true. Not exactly the way we would want to do it, but anyways, here's another one. Derivative of 1 over x. Well, what's 1 over x? This is just the derivative with respect to x, of course. X to the negative 1. That's still an n. N is any real number. Well, this is just negative 1 x to the negative 2, which is just negative 1 over x squared. So you could think about it that way, or you could think that if x is in the denominator, you just increase it a number and it's alternating with the negative. So if I was to differentiate this again, I would get 1 over x cubed. Wrong. Shouldn't have said that. I'd get 1 over 2x cubed, sorry. Because that 2 would come out in front. So ignore that. Yeah, all we want to do is that's the easiest way to do it, is change it to a negative power. That's really all there is to the power rule. Except for, I've got a little something that we're going to learn in the next episode, video, whatever you want to call it. But if we had x to the 5 times x to the 3, we're differentiating both of those, you might think that you can just do 5x to the 4 times 3x squared, but that's not actually true because it's not 15x to the 6. It's actually, if we just combine these, x to the 8, we get 8x to the 7. So, not okay. Do not do this. We will learn in the next episode video what we're going to do instead of that. And yeah, thanks for watching.